How can you understand climate model data easily? Imagine trying to read a weather forecast for the entire planet. Climate models are like giant digital maps that show how Earth's climate might change over time. They split the world into tiny three-dimensional boxes and use math to see how air, water, land, and ice interact. The results tell us about future temperatures, rainfall, wind, and more, based on different greenhouse gas emission scenarios. To make sense of this data, start by looking at multiple models together. These are called model ensembles. When many models agree on a trend, like global warming, your confidence in that prediction grows. If some models show different results, it shows there's uncertainty. Visual tools like scatterplots or maps can help you see where models agree or differ, making it easier to understand the bigger picture. Next, pay attention to the scenarios used in the models. Some assume high emissions, while others assume low emissions. Knowing which scenario the data is based on helps you see what actions might influence the future. Also, check the time frame. Are these projections for the next decade or the next 50 years? This context helps you connect the data to real-world actions and timelines. Using visualizations is key. Graphs, maps, and charts turn complex data into pictures that show trends and extremes clearly. For example, a map showing temperature increases across regions can make the impacts more understandable. But be aware that how data are displayed, like averages or ranges, can influence what you interpret. Understanding the main variables in climate models is also helpful. Besides temperature and rainfall, models estimate things like snow cover, ice melt, and wind patterns. Knowing what these variables mean helps you see how Earth's climate responds to changes in greenhouse gases. Remember that models are not perfect. They include uncertainties because natural variability and process differences can lead to different results. Recognizing that models give a range of possible futures, not exact predictions, is important. Sensitivity tests, which see how small changes affect outcomes, can show how reliable the projections are. Finally, take advantage of online tools that let you explore climate data yourself. Many websites offer user-friendly interfaces where you can see local or regional climate forecasts. These tools often include explanations and visual aids, making it easier to understand what the data mean for your area. By following these steps, you can better interpret climate model data and see how it relates to environmental challenges and sustainability. It helps connect complex science to real-world issues like global climate change and ecological impacts, making the information more accessible and useful.